Okay, the next thing we'll talk about is titration. And titration is a technique that's employed in chemistry in order to make quantitative uh, analysis, in order to perform quantitative analysis on reacting solutions. So, how do we use it when we're talking about acids and bases? So typically we have a known concentration of either your acid or your base, and you slowly add to that solution um, of acid. You would add a base, and of a base you would add an acid. And we also use an instrument called a pH meter or indicators. And where we want to identify what is the equivalence point of these reacting solutions. And the equivalence point is when the moles of acid is equal to the moles of base. And we say that that's our neutralization point. So if we were to take a titration of a strong acid with a strong base, we would have what we call the classic pH curve. So what happens is that you're going to start out, so if you're adding a strong base to a strong acid, you're going to start out with a very low pH, and the pH will change very slowly, and just before and after the equivalence point, which in this case would be 7, just after the equivalence point, you'll have before and after this sharp, rapid change in pH. And so what we know is that at the equivalence point, you have an equal number of moles in acid, and the equivalence point is always at the midpoint of this spike. Okay, so that's an important place in a titration curve. So you identify where that vertical spike is, and you take the midpoint, and that midpoint is where your equivalence point is. So the the solution contains H2O and cations from the base and anions from the acid. And as more base is added, the pH just eventually levels off. The solution becomes all base. So what we see is this very long, sharp spike. This is for the strong acid, strong base. Now, what if we have a weak acid with a strong base? Well, our pH is going to start up a little bit higher, and what happens is that you'll still get that spike. It won't be as long of a stretch vertically. And the midpoint in this scenario is not necessarily at 7, even though it's the equivalence point. It doesn't necessarily mean that it's at 7, because in this scenario, it's going to be a little bit above 7. And the reason for that is because at the equivalence point, there is some of your conjugate base still present. And so if there's conjugate base present, then it's going to register a little bit above 7. So in order to determine qualitatively when I've reached this equivalence point, I use indicators in my solution. And there are indicators that have specific intervals. So one indicator, methyl red, has a pH interval of 4 to 6. So the color change occurs between 4 and 6. But you want that color change interval to be completely within the range of the spike. So here, this indicator, phenolphthalein goes from clear to pink, anywhere between clear to pink, anywhere between 8 and 10. And as long as that spike is within the as long as that interval falls within the spike, then it is an appropriate indicator. So if I go back to this one, the strong acid with the strong base, I could use, even though the midpoint is lower, still that color change interval is within the range of the spike. I could also use methyl red for this in order to see when I've reached my equivalence point. Okay, so, and this would all be done systematically as you're slowly adding, regularly adding your NaOH. You have a pH meter that at every second or 2 seconds measuring the changing pH. Okay, that's a nice lab. You're going to do a lab like that. Well, you're going to do the lab virtually. So then there's also the titration of a weak base with a weak acid. So the weak base, so if I'm titrating with a strong acid, a weak base with a strong acid, I'm going to start out, my weak base is going to have a little bit higher pH, not quite up to 14 though. And then there's going to be my spike, same thing. But now look what happens. I couldn't use phenolphthalein because the range, the interval, the change interval, color change interval of that indicator is not along the spike, the vertical spike. I could use methyl red because here's where it is. It's at 6. And so that color change interval between 4 and 6 for methyl red falls within my spike there. And it so happens that the equivalence point you would find, the midpoint, again, is not at 7. This time it's a little below 7. And that's because there's a conjugate acid present with the weak base. And in fact, on each of these, you're going to have a point. I'm going to just go back to this one because this is a better example to use. You're going to have a point, especially on these weak acid, weak base, and weak acid, strong base, or weak base, strong acid. At the halfway point, we call this the half neutralization point. At the half neutralization point, this solution would behave as a buffer. And that's an important point to at least be able to identify. You don't have to know all of the quantitative aspects of that. And then it would be the same situation up here, where at half neutralization point of this weak base, so let's say it took 40 milliliters of hydrochloric acid to get to the equivalence point, then at addition of 20 milliliters, that solution that I have in my reaction vessel would be considered a buffer. Again, this is just a qualitative characteristic of a titration curve that I would like you to know. You don't have to understand all the math that goes with it. This is just another strong acid, weak base. This one is a weak acid and a weak base. Weak acid, weak base has kind of a weak pH curve, and that's what it would look like. And then we can also show titration of a polyprotic acid. So that's just an acid that would release more than one hydrogen ion. So you would get 2 spikes in that. And so clearly, because the equivalence point for each of those hydrogen ions that are ionizing are at a different point on the vertical scale of this, I would have to use different indicators to identify the equivalence point. Say this one was between 4 and 6, I'd use methyl red. Say this one was between 8 and 10, I'd use phenolphthalein. I'm going to stop there.